Hi everyone, Mrs. Danielson here, and today we're going to talk about your 6 trigonometric functions and reference angles, two things we've already been working on, but today we're going to combine them into a single topic. We're going to use them both at the same time. So let's go ahead and switch over to my iPad and let's get going on combining your 6 trigonometric functions and reference angles. Okay, so the first thing we need to do is we need to take that right triangle that we've already been using. But what we need to do is we need to take that right triangle and we need to put it in a coordinate grid, right? So we need to take that right triangle and we need to take it into our XY plane. So here I am going to put this into an XY coordinate grid. Here's our X and Y axis, our X and our Y. And I'm just going to make my right triangle here so that I have an X and a Y and an R. So now here's my angle, and my opposite side is now going to be Y, and my adjacent side is now going to be X. The hypotenuse I'm now going to call R. So I've just taken that right triangle and I've just settled it here into my coordinate plane. Okay, so I have now an X and a Y and an R instead of adjacent, opposite, and hypotenuse. So what that means, I can take my 6 trig functions, and instead of always saying opposite, adjacent, hypotenuse, I can now use X and Y and R instead. So that means that my sine function, instead of opposite over hypotenuse, is now going to be Y over R. And cosine, instead of calling it adjacent over hypotenuse, now in that coordinate plane, is now going to be X over R, and tangent, instead of opposite over adjacent, TOA, opposite is now Y, and adjacent is now X. Okay, so we're just doing a little bit of substitution there is all. Cosecant, which was your reciprocal of sine. Okay, we're just replacing a couple things here. It's the reciprocal of sine, so it's now R over Y. Secant, reciprocal of cosine, is now going to be an R over an X. And cotangent is now going to be X over Y. A couple things you need to watch out for now is we have some X and Y's in our denominators, right? So when you're doing tangent, your X cannot be 0, right? When you're doing cosecant, your Y cannot be 0, because if it is, right, then your cosecant is undefined. When you're doing secant, your X cannot be 0. And when you're doing cotangent, your Y cannot be 0, right? When any of those things happen, then you've got an undefined trig function. An example of that, when that might happen, let's say you're doing tangent, and let's say we wanted to know the tangent of 90 degrees. Okay, right, what that would look like if we take a look at that in our coordinate plane. Here's an X and Y axis, and I'm talking about 90 degrees right here, right? So the coordinates there at 90 degrees are 0 and 1. Our X is 0 and our Y is 1. So tangent of 90 degrees, right? Tangent, we have it right up above there, is Y over X. So our Y is 1, our X is 0, and you can see we have a problem there, right? Because we can't have a 0 in the denominator. So that means the tangent of 90 degrees is undefined. Okay, so these undefined trig functions occur at the 90-degree mark. So 90 degrees, you can have it there, 180 degrees, 270 degrees, 0 or 360 degrees, or where these are going to occur. So you need to watch out for those at the 90-degree marks, that you could get an undefined trig function at those spots. Okay, now let's talk about the signs of our trig functions. We have our our 4 quadrants, 1, 2, 3, and 4. And in different quadrants, different trig functions are different signs, positive or negative. So let's talk about those, the signs of our trig functions in the different quadrants. In quadrant 1, everything is positive. all trig functions are positive in quadrant 1. In quadrant 2, sine and its reciprocal cosecant are positive. The other 4 trig functions are negative in quadrant 2. In quadrant 3, tangent and cotangent are positive. The other 4 are negative in quadrant 3. And in quadrant 4, cosine and its reciprocal secant are positive. The other 4 are all negative. Okay, so let's just take a look at what that looks like, right? So again, these are our 4 quadrants, the way they're numbered, right? This is quadrant 1, 2, 3, and 4. Okay, so that means that in quadrant 1, everything is positive. In quadrant 2, sine and its reciprocal are positive. Quadrant 3, tangent and its reciprocal are positive. And in 4, cosine and its reciprocal are positive. So if we go from 1 to 2 to 3 to 4, that's what it looks like. Now, to help us kind of remember what's positive in what quadrant, we can just look at these first letters. We get A, S, T, and C. So we have a little phrase to help us remember what's positive in which quadrant. And that's all students take calculus. All A, students, sine, take, tangent, calculus, cosine, to help you remember, again, which trig functions are positive in which quadrant. Those are the positive ones. The other ones are negative. Okay, so let's figure out why we want to know this, right? Let's start putting some things together. Okay, let's say first we need to get an angle. Okay, so let's say 45-degree angle. We need to find the reference angle for that. Okay, what is the reference angle for 45 degrees? The reference angle we've talked about before is the angle that gets you to the x-axis the quickest. So the reference angle for 45 degrees is 45 degrees. It's 45 degrees that gets you to the x-axis the quickest. Let's do one that's a little bit harder than that one. That one's pretty silly, actually. Let's say our angle is 135 degrees. What's the reference angle for 135 degrees? It's the angle that gets us to the x-axis quicker, the smallest angle to get us to the x-axis. In this case, the smallest angle to get us to the x-axis is this one right here. Okay, the difference between 180 and 135, which is 45 degrees. So the reference angle for 135 degrees is 45 degrees. That's the difference between 180 and 135. Okay. Let's do another one. Let's do 210. what's the reference angle for 210 degrees? Right, the smallest angle that'll get us to the x-axis, or the difference between 180 and 210. So that's going to be 30. 30 degrees is the reference angle for 210 degrees. Okay, let's do one more, just reviewing what a reference angle is, and then we're going to put these things together. Let's do 345 degrees. The reference angle for 345 degrees. The smallest angle to get us to the x-axis would be this one right here. And what is that? Right? That'd be the difference between 360 and 345, or 15 degrees. Okay. So this is finding a reference angle. Okay. So now we need to put some of this together. Okay. Here's why we're doing this. Let's say I want to find the sine of 240 degrees. 240 degrees, that is, where is that at? Right, that's going to be over here in quadrant 3, 240 degrees. What's the reference angle for 240 degrees? Right, what is this angle right here that gets me to the x-axis? It's the difference between 180 and 240. And that is 60 degrees. Okay, so what is the sine of the reference angle? What is the sine of 60 degrees? Well, let's remember our 60-degree angle, right? Our 60-30 triangle. This would be 1, 2, and the square root of 3. So what's the sine of that 60-degree angle? Well, it's opposite over hypotenuse. So that's the square root of 3 over 2. All right, but we're actually solving for the sine of 240, which is in quadrant 3. And is sine positive or negative in quadrant 3? All students take calculus. This is sine. So it's not positive. Tangent's positive in quadrant 3, not sine. Sine would be negative in quadrant 3. So the sine of 240 degrees would be negative square root of 3 over 2. So you use the reference angle to solve for the sine, and then you pick whether it's positive or negative based on which quadrant it's in. Let's do another one. How about cotangent of 495? Okay, first we need to figure out what the reference angle is for 495, because that's a really big angle, right? 495, wow. So for that one, we go all the way around. That's 360. And then what do we have left? We have 135 left over. All right, so that's going to put us over here in quadrant 2. That is 495 degrees. Okay, so what is the reference angle right here that takes me down to the x-axis? Let's see, 360, 135. So that would be 45 degrees. Right? 495 minus 360, yes, that's right. So what I'm actually solving is what is the cotangent of 45 degrees? Well, let's take a look at our triangle here really quick. Remember what the cotangent of 45 degrees is, right? And we had figured out before a 45, 45, 90 triangle, right, with a hypotenuse of 1. These were our sides, remember that? So cotangent of 45 degrees would be the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. Okay, but we're not solving for 45, we're actually solving for the cotangent of 495 degrees. So we're in quadrant 2. Is cotangent positive or negative in quadrant 2? All students, so sine and its reciprocal are positive in quadrant 2, but everything else is negative. So it's actually going to be a negative 1, and that's your answer. Last one, let's do the secant of negative pi over 4. I want you guys to do this one on your own. Okay, so you're going to pause the video, you're going to come up with an answer, and then we're going to see if we get the same one. Okay, all right. Hopefully you came up with an answer. Now let's see if we have the same one. All right, so here we go. All right, so let's find out what is the reference angle for negative pi over 4, right? The reference angle. So negative pi over 4 is right there. Negative 45 degrees puts us in quadrant 4. Okay, the angle that gets us back up to the x-axis is the same angle, right? Pi over 4. So we're interested in the secant of pi over 4. Okay, that same triangle we just used, this one right here. Okay, all right, so secant is r over square root of 2 over 2. So that's going to be 2 over the square root of 2. But you can't have a square root in the bottom, so we have to take care of that by multiplying top and bottom by the square root of 2. So that's 2 square root of 2 over 2. And that leaves us with the square root of 2. All right. So the secant of 45 degrees, or pi over 4, is the square root of 2. But this one isn't actually 45 degrees. This one's actually the secant of negative 45 degrees. It's in quadrant 4. So we need to take that square root of 2 and figure out if it's going to be positive or negative based on the fact that it's in quadrant 4. All students take calculus, right? So that means cosine and its reciprocal, which is secant, are positive in quadrant 4, everything else is negative. So that means that our answer is positive square root of 2. And there you have it. Did you get that answer? Kind of a tricky one there for sure. Okay, that's it for using our 6 trig functions and reference angles to solve for them. Everybody have a great day. Thanks.